Hi Math055 students. So today we're going to do the first part of 8.1, which goes over solving principal square roots. Our first example is 4x squared is equal to 100. So to solve this, you're going to start like you usually start solving an equation. In order to solve this, you probably would notice that you would need to divide by 4 on both sides. Which leaves you with x squared is equal to 25. Okay, in order to figure out x squared equals to 25, what we really want to know is what would x equal? So if we were to take the root of x squared and just put x, we would say that's equal to the square root of 25. And so then you could simplify the 25 because you know that the simple square root of 25 is 5. And so x is equal to 5. Now when you're solving these, you're going to have a positive and a negative answer. The reason is because, of course, a negative 5 times a negative 5 is also equal to a positive 25. So your answer needs to include both the negative and the positive answer. So you would say x is equal to 5 or x is equal to a negative 5. You could also use the plus minus, and sometimes that plus minus is a little bit faster than rewriting everything else. So you could also say x is equal to the plus or minus 5. Okay. Okay, so that's the first example, and oh, my computer went down. Okay, it's going to take me just a second to get back up. Okay, so on your handout, the next problem is for you to solve, and so I'm going to go ahead and, let's see, am I right on that? Yes, it is. So it's your turn 1. So erase that. And we have solve 3x squared minus 4. And that is equal to 0. Okay. Okay. Whoops, it's not either. Sorry, I skipped one. The computer turning off kind of made me jump ahead. So it's 3y squared is equal to 108. Okay, just like before, you're going to divide both sides by 3. So we've got y squared on the left. 3 goes into 10 3 times, got 1 left over, so we end up with 36. So y squared equals 36. So again, we're going to isolate this variable y, and by doing that, we need to put the 36 into a radical. So we're saying y is equal to the square root of 36. And so the square root of 36 is 6. So y is equal to 6. And remember with these, you're going to write the plus and the minus. So you could say plus or minus 6, or you could just say 6 or a negative 6. Okay. All right, so let's look at example 2. So example 2 on your paper is 3x squared minus 4 is equal to 0. All right, so if you were solving this equation, you would probably just naturally say, well, I need to add 4. So if you add 4, now you've got 3x squared is equal to a positive 4. And then the next step would be to divide by 3. So you've got x squared is equal to 4/3. Okay, so again, we've got this x squared, but we want to know what x would equal. And so I'm going to finish solving it over here. I hope that's not too confusing for you. So if we got x squared is equal to 4, then that means x, or 4/3, x would be equal to the square root of 4/3. And you probably are noticing that 4 is a perfect square, but 3 is not. So what we could do then is factor the 4, so that it would be 2 times 2, right? And so we could pull the perfect square of 4 out, and then we would leave the 3, here, let's do it this way. Because the 3 is in the denominator, it would need to be underneath it. So we could write it just like I wrote it, a -2 over the square root of 3 is equal to x. But remember, this 2 could be a plus or a minus, and so you could say x is also equal to a -2 over the square root of 3. Now, if we wanted to rationalize the denominator, for some problems in the future, you may need to do that. And so if you wanted to rationalize the denominator, I'm going to go ahead and erase this. So right now we have x is equal to plus or minus 2 over the square root of 3. And so if we wanted to rationalize the denominator, we would multiply both sides by the square root of 3 over 3. So here we would have 2 square root of 3. Here we would have 3 times 3 is 9. And what's the square root of 9? It's 3. So we would have 2 over 3. So we would have, as a final answer, x is equal to the plus or minus 2 times the square root of 3 over 3. Okay. Okay, and then the next one is your turn solve. And so let's go ahead and look at that one. I'm going to let you get started with it while I erase. So to solve this, we're going to start by adding the 16. So now we have 3x squared is equal to 16. We'll divide by 3, and so we have x squared is equal to 16. So we don't want x squared though, right? We want x. So we write x then is equal to the square root of 16 over 3. I left that 3 off. Here, let's write it here. There we go. So x is equal to the square root of 16 over 3. Okay, but that can be simplified because 16 is a perfect square root. So I am going to erase the first part of this. So I've got x is equal to the square root of 16 over 3. So to simplify that, the square root of 16 would be 4. So x could be equal to a positive 4 on top or a negative 4 plus minus over the square root of 3. Now, just like we did a minute ago, we could rationalize the denominator so that we could get rid of that denominator. You don't have to do this always, because when you do that, as you noticed in the last problem, we still had a radical because we had a radical on top. But at times you may be asked to do that. So plus or minus, and then we're going to put 4 over the square root of 3, which is what our answer is. And then to rationalize the denominator, we're going to multiply by 3, because 3 times 3 gives us the square root of 9. So we get 4 times the square root of 3 over 3 times 3 gives us 9. The square root of 9 is 3. So this could also be an answer. And again, you would need to add that plus minus. So plus or minus 4 times the square root of 3 over 3. Okay. All right, great. Let's look at the next part. So now we're looking at example 3. So example 3, we have 16x squared plus 25 is equal to 0. All right, so we would begin by subtracting the 25. So now we have a negative 25 on the left, and then we would divide by 16. So we would divide by 16. Okay, so we've got x squared is equal to a negative 25 over 16. The next step would be putting the negative 25 16 into a radical notation. Now, excuse me, when we do that, on the left, the x becomes all alone, but we also know that we really don't want a negative 25. So that means we need to factor that part. So that would equal 25 times a negative 1 over 16 square root. Okay? And so if you remember from our last lesson in 7.8, a negative 1 is going to equal that I didn't write that as pretty as I usually do. Okay, so what we're going to do to simplify this is, again, I'm sorry that I have to rewrite, but I'm going to erase this top part. Okay, so now I have x is equal to the square root of 25. I simplified the negative 1 over the square root of 16. So the square root of 25, of course, is 5. The square root of 16 is 4. And then times I. And that would be your final answer. And of course, we would want to add the plus minus. Okay? So x is equal to plus or minus 5/4 I. Okay, good. All right, so that leads us to your turn 3, which is to solve. So let's go ahead and do that one. Again, I'm going to give you a chance to kind of write it down and start solving it while I write it down slowly. Okay, to start off, we would go ahead and take away the 16. So we have a negative 16. And then we've got 9x squared is equal to that negative 16. Okay, then we would divide by 9. So we have x squared is equal to a negative 16 divided by 9. In order to get an x all by itself, we need to find the square root of a negative 16 over 9. Okay, so the square root of a negative 16 we can't do, but we sure could factor that so that it would look like 16 times negative 1 and then over 9. So then 16 and the 9 are now free of that negative 1. Remember that a negative 1 is going to equal the I. So the square root of 16 is 4. The square root of 9 is 3. So our answer would be 4/3 I. And we would want to add that plus minus at the beginning. So x is equal to plus or minus 4/3 I. Okay, so our next example is example 4. I'll give you just another second to copy that down if you need to. All right. So the next one, and again, this is example 4. We have x squared plus 2x plus 1 is equal to 5. Okay, and so looking at this, maybe you're noticing that 1 plus 1 is 2, and 1 times 1 is 1. So this can be factored to x plus 1 squared. So x plus 1 squared is equal to 5. Okay, so to eliminate that square, we're going to write x plus 1, but that puts the 5 inside the radical. Okay, and so then to continue solving it so that we have x all by itself, we would take away 1. So we've got a negative 1 plus the square root of 5. Now remembering that we don't know if that 5 is a negative 5 or a positive 5, so we're going to go ahead and put a negative 1 plus or minus 5. Okay, so this canceled out. So we have x is equal to a negative 1 plus or minus the square root of 5. Not so bad, huh? Okay, and then the last one in this first part of 8.1 is the your turn 4. And so I'll give you another minute to write this down, and then we'll go ahead and start that, the your turn 4. Okay, so your turn 4, we've got x squared minus 4x plus 4 is equal to 10. I bet you are getting so used to factoring that you're noticing this factored would be x minus, x minus 2 squared. I mean, it's this, but we simplify it by saying that, okay? X minus 2 times x minus 2. Negative 2 times the negative 2 is a positive 4. A negative 2 plus a negative 2 is a negative 4. And that all equals to 10. Okay? So this is squared. This is not squared. So if we pull out the x minus 2, then that means it would equal the square root of 10. Then we would go ahead and solve this. So we've got plus 2. So x is equal to 2 plus or minus the square root of 10. 10 factored out would be 2 times 5, which there's no perfect squares with 2 or 5, and so this would be our final answer. Okay, so that's the first video for 8.1. There's a second video also for 8.1 that you can watch after you feel comfortable with this part of it. Okay, great. Bye-bye.